Okay, so we're going to finish up these notes today, which is constructing confidence intervals for means. I think we're going to have time to finish them. Oh, before we start this part, we need to finish down here. That's right. So we need to finish this example, right? We got up to the margin of error, but we haven't finished it. And so this example is talking about at the mean age that children begin to start talking or combine words, right? And so it gave us all of these variables right here. And then what we did was we found the critical value. And so remember, the critical value is just the value that kind of is the boundary on your confidence level and like the area of your confidence level. So we found our critical values, which are these two things. And then we found our margin of error, which you calculate like this, right? And so after we find the margin of error, we're going to need to find these two things, and that's what actually forms our confidence interval. And so here what we get is, so X bar, remember X bar is, and so let me put this in a different color. X bar here is the point estimate. So don't forget that definition. So remember, the point estimate is always just the sample statistic. And then E is that margin of error. So if we start to find them, X bar minus E, that's going to equal, what's X bar again? 16.5 or 16.51, and then minus E, which is going to be 2.55. And so here, X bar minus E is equal to, what's that equal to? I don't actually have the answers anymore. 16.51 minus 2.55. That gives us 13.96. And then next I need to find X bar plus E. So that's just going to be 16.51 plus 2.55. And so when you do this, you're going to get 16.51 plus 2.55, 19.06. And so our confidence interval is going to start at the smaller number and then work its way up to the bigger one. So, 13.96 is the first part of our interval. And then it's going to go all the way up to 19.06. Hang on, I'm going to shift this a little bit because I'm running out of room. So do you guys have any questions up to this point about how to construct the confidence interval?
Nope.
Okay, cool. So then the last thing that we need to do is interpret this. And so that's step 6, which is why I kind of moved everything around because I needed space to write this sentence. But so what you're going to do, and so if you look back, so real quick, I'm going to go back to our 7.1 notes. And our interpretation is going to look a lot like this, right? We are however % confident that whatever we're talking about is between the two numbers that we found, right? And so if I go back over here, since I was using a confidence level of 98%, I'm going to start out my interpretation by saying we are 98% confident that the mean age at which children begin to combine words is between 13.96 and 19.06 months. Or you could even just round this to say between 14 and 19 months. And so that's what your interpretation would look like. And so real quick, what I'm going to do is I'm going to kind of show them side by side. Right, so if I zoom in on both of these, so there's that one. And I kind of compare this. So real quick, I'm going to kind of erase all of this for now. And so here we are C% confident. So that's that 98% confident. And then insert population, that's the mean age at which children begin to combine words, right? And then here, the last one, insert the numbers found. Oh, it's a bad color, do yellow. Insert the numbers found, that's just 14 and 19 months. So yeah, these are, on the left is the 7.1 notes, on the right is the 7.2 notes, the example that we're working on. And so I just kind of compared the generic interpretation versus the one I wrote down. So do you have any questions about this problem or how to interpret anything like this? All right, so that's how you construct a confidence interval for, I'm gonna get rid of my 7.1 notes now, but yeah, so that's how you do it. But so this whole page right here, so if I zoom out to fit the whole page, this is how you construct a confidence interval when you know sigma, right? So that's the key thing here, is that we know what sigma is equal to. And so what I showed you here is how to solve all of this by hand. We could skip a lot of these steps by using a function in your calculator. So if you go, everybody get out your calculators right now. You should have them near you. Oh man, there's mine. But so when it came to hypothesis testing, and I wanted to test sigma, real quick. So when I'm hypothesis testing and I want to test mu given sigma, what function in your calculator are you going to use?
Could you say that again?
Yeah, so if you are trying to test mu and you're given sigma, what function in your calculator are you going to use to enter all of your variables and come like get your p-value and stuff like that? So your option, wait, yeah, z-test, right? And so here you're going to use z-test. And so everybody go to where you would find z-test, so stat and then tests. If you scroll down, if you like keep scrolling past the first page, so notice everything from 1 to 6 says test, but then if you start looking at 7, it says interval. And so it's not a coincidence that that says interval, and we're constructing confidence intervals. And so here, when you're testing mu and you're given sigma, you're going to use z-test. But when you're estimating mu and you're given sigma, which one do you guys think you're going to use? Like which one on this tests page on your calculator?
Interval t?
Not t, it's going to be the same letter as right here, right? And so it's still going to be z, but with interval now, and there's no dash for whatever reason. I don't know why there's a dash with z-test, but not z-interval. And so yeah, if you put everything into z-interval, so if we do this example above, so example above, done again. And you just put everything in, so you go to stats. So on the top, it's going to say input data versus stats. You're going to select stats, like the same thing we were doing with the testing functions. You're going to input sigma, which was, what was it here? 9.59. X bar was that 65 point or 16 point, 0.51. N is 77, and the confidence level is 0.98. And so here, this is how it would look in your calculator. So stats, sigma 9.59, X bar 16.51, N 77, C level 0.98, and then you just hit calculate, and you're going to get the same interval that we found. So here are the interval that you get. So confidence interval 3.968, 19.052. And so if you compare our two answers, they're very, 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 very close. So this answer compared to this answer. And so the reason that I showed you how to do it by hand is because I am going to want you to find margins of error. And notice when I do it this calculator way, so the second way done in blue, I never used the margin of error, but I am going to ask you to calculate that. And so that's just this formula right here. So make sure you know this and how to find these critical values, because I'm going to ask you to do those two things. And so that's why I had you do it by hand. But this is how you're going to use your calculator. For the next one, we're just going to go ahead and use our calculator and not do it by hand. But do you have any questions between the two different ways that I did it, either by hand or using the calculator? Does everybody see the difference and understand the difference? You'd still have to interpret it from here. And so when you're doing it using your calculator, you can just skip steps. Unless I ask you for this, you can skip steps 3, 4, and 5, and just go straight to Z interval. So yeah, any questions?
So we used the Z test for that one because we were given sigma, and that's why we're using the Z test for this one, for the when we were doing it not by hand.
Wait, what do you mean? The Z test,
So we use it. Yeah.
This is just kind of like getting you thinking about how it relates to chapter 8. And so this is for chapter 8, and then this one is for chapter 7. And so we don't care about this one anymore. Okay, you definitely care about this because this one is what your exam is about. But here, we're not actually going to be using Z-test anymore for confidence intervals. And so the only reason I wrote this down was to kind of get you thinking, like, if you're using Z-test, then whenever like the conditions are required for you to use Z-test, you're also going to use Z-interval. Does that kind of answer your question?
Yeah.
Okay. So yeah, like if I had, when I had that whole like, are you testing mu or are you testing p? If you're testing mu, then you either know sigma or you don't know sigma. So you guys remember me making this? And then if you know sigma, you're going to use Z-test. If you don't know sigma, that's when you use T-test. Regardless of what's here, you use one prop Z-test. So this is for hypothesis testing. We can make something almost exactly the same for confidence intervals. And so we haven't actually done the P for confidence intervals, but just kind of pretend that you know what I'm talking about. And so again, if you're estimating mu, you have to break it down into these two things. Either you know sigma or you don't know sigma. If you know sigma, you're going to use Z interval. If you don't know sigma, you're going to use T interval. And when you're testing for P, you're going to use, what is it called again? I think it's like one prop Z. Hang on. One prop Z int. And so notice the only thing that changed when I went from hypothesis testing to confidence intervals is everything went from test to interval. And so here you just have to be very careful. You have to pay attention to what it's asking you. If you're given mu, so this is if given mu or p, and this is if trying to estimate mu or p. Does that make sense? Is everybody kind of okay with this, with the difference between chapter 8 and chapter 7 now. Okay. Okay, so yeah, I'll keep this page in here for when I upload these, but yeah, so it's basically just the same process both times, either if you're testing or you're finding an interval. You just have to know which one in your calculator to use, right? So if you're given mu or p, you know you're going to be using test. If you're not given mu or p, you know you're going to be using interval, but it's usually pretty clear. So I'm going to scroll up. If you need me to scroll back down, just let me know. But it's usually going to be pretty clear in the wording of the question because it's going to say construct a confidence interval, right? Or it's going to say something like, let's see, what does this one say? Construct a confidence interval. And so it's going to be pretty clear. I want to say for the hypothesis testing ones, it actually says like perform a test at the 5% significance level or something like that, right? So if it says test, you're going to use test. If it says interval, you're going to use interval. But so, yeah, any questions before I move on and talk about and do the example for when we don't know sigma?
Can you scroll down real quick to the little chart you just made?
Yeah, there you go. So yeah, this chart's missing some stuff too, right? Like it doesn't have the requirements, it doesn't have like the actual steps. It just kind of is telling you what tests you can use or what functions in your calculator you can use. I'm sorry.
Okay, thank you.
You're welcome. But yeah, so any other questions about anything? Oh, that's what I forgot to talk about in the beginning. I'll talk about this at the end. But did you guys all see, so while I'm kind of leaving this up here, did you all see that Cal Poly has changed its grading scale option? So you now have the option to choose how you're graded. And so what I mean by that is you can either get, so option 1, I think, is like the standard grading scale, which I don't, if you're failing and you know you're going to fail, I do not recommend that. But so option 1 is like you either get an A, B, C, D, or F. Option 2 is you either get an A, B, C, or no credit. So if you were going to get a D or an F, you can opt for no credit instead, which doesn't affect your GPA. So it's basically saying you get like a free retake. Well, not free because you still have to pay for the course, but like, I mean like free in the sense of like it's not hurting you. And then the third option is either credit or no credit, which I do not recommend because if you're passing and you get credit, that does not affect your GPA in the same way no credit does. So if you were getting an A in the course and you opt for credit, you're not going to get that A GPA, if that makes sense. And so choose between those 3 options very carefully. There's an email that was sent out about them. I want to say it's per course that you get to choose this grading option. And so, yeah, any questions about that? So think very carefully. I want to say you have until May 7th to make that decision. Think very carefully about what you want to do. That May 7th deadline might be wrong. So don't quote me on that. This is now.
It said May 8th was the dedeadline, but I'd suggest putting it in by May 7th, though.
Yeah,
That makes
like
more
just pretend the deadline is May 7th then, just in case. I would suggest the best option is the second option, A, B, C, or no credit. Because if you're passing, then you still get the GPA for like doing that. Like if you get an A in the course, your GPA is still going to say, hey, I got this A. But if you fail, your GPA is not going to reflect that you failed that semester. It's just going to say you don't get credit for this course, and so you still have to retake it, but it's not like impacting you at all.
So like we are free to retake it if we took like option B.
And
like,
get
with
credit, yeah.
Okay.
Yeah, because like I don't know if you guys were seeing, I don't know if you guys look at the Cal Poly Pomona subreddit at all. This is how I found out about it.
I saw the email. I saw the email to like the CPP thingy.
Yeah, I don't actually look at those emails. I have a filter to get rid of those. But there was something going around yesterday where they wanted it to just be A, B, or C only. So if you were to get an F in the course, all of a sudden you're at a C now, which if that had passed, I think I would have just stopped teaching. What's the point? if everybody's gonna pass. So with this no credit option, it's good because if you did not put in the work for whatever reason, either you got lazy or you were impacted by the coronavirus negatively, then that no credit option is there so that you can just kind of say, hey, I messed up, but I don't want it to count against me. And let me try again. So yeah, option B is probably the best option in my opinion. But I mean, if you're passing the class, then there's no reason to go to option B. You can just stick with option A. Okay, but yeah, so that was a little tangent. Everybody should have this chart down now that I'm done talking about that. So I'm gonna go back up and I'm gonna scroll to the other example. Although I'm gonna be scrolling back and forth quite a bit. So if I go back up here, this is the first example that we left off on. Find the critical values for each of the following scenarios with C equal to 0.95. And in this first one, we are not given the standard deviation or the population standard deviation. When I'm not given population standard deviation, I'm not allowed to use inverse norm. When I can't use inverse norm, I can't find that critical value, right? And so to work around that, there's this table. Some of you may have seen this before. This is called the critical values for the student's t distribution table. And these are all of the critical values. And so I'm not going to have you do this. So this example that we're doing, I'm just going to kind of go over it really quickly, but I'm not going to have you do this by hand again. And so you're not going to need this table. I just kind of want to show you that it's representing almost the same thing as the Z sub C critical value, but T is slightly different, right? And so what you're going to do to read this table, how you read it, is so let me zoom in a little bit. These are all of the degrees of freedom. Do you guys remember what degrees of freedom is? We talked about that before we went online. So if I go back up to, where is it? The example that we were doing up here. N is equal to 1972. So what's the degrees of freedom equal to? You guys remember? I think it's on a picture somewhere. So yeah, what would my degrees of freedom be here using that? Nobody? Nobody wants to answer? Okay, I'll just write it down. Degrees of freedom is n minus 1. So here, you're going to have 1972 minus 1. It's going to equal 1971. Are there any questions about subtraction? Nobody answered my question. Do you guys remember this? The degrees of freedom stuff? So this is the one where we talked about those exam scores. We did a whole example where the first 2 exam scores, depending on what you get on those, your third exam score is fixed, right? And so only 2 of your 3 things were free to vary. It's kind of the same thing here. If I had 1900 exams, then the first 1899 of those exams can be whatever they want, but that last exam to get a certain grade in that course is stuck, right? And so here, degrees of freedom is 1971. And so when you scroll down to that table, you're going to go to that degrees of freedom, but it's not there. So you're just going to go to the next lowest one, which is going to be 1,000. And again, you guys aren't going to need this part of it. So you're going to use 1,000, and then you're going to find the confidence level that you were given, which in this case is 0.95. So right here. And so I'm going to go down until I get to my degrees of freedom. And so my critical value would be 1.962. And what that means is, if depending on that would mean this is negative 1.962 and this is positive 1.962, which is the same kind of picture that I have right here when I know sigma, right? So using the table, you get that T sub C is equal to 1.962 and negative 1.962. But so yeah, that's how you're going to use that table. I don't think I'm going to have you use it. I might have you find these critical values online, but it's just going to be a matter of inputting your degrees of freedom, and then it'll give you an answer out. But so yeah, that's how you do this problem. So let's go and look at the example for finding a confidence interval when you don't know sigma. So here, what you're going to do, wait, real quick, can you guys still hear me? I think you guys haven't talked to me in a while. Should make sure it's not like freezing. What happened in my calc class?
I can hear you.
Okay, cool.
Yep, we can hear you.
All right, so what's it called? Here, this procedure is if you were to do it by hand. And so I'm not, we'll kind of go over it, but we're not going to do the example by hand. So here, the first thing that you do is you always check the requirements. Then you compute X bar and S if you're not given those two things. And then you're going to define the degrees of freedom, which is n minus 1. And the critical value, which is T sub C in this case. And so step 3 is the only thing that kind of changed here from this box up here, right? When you know sigma, step 3 is the only difference. Step 4 is the same, compute the margin of error. And it's still going to be given by E, and it's still the critical value times the standard deviation over the square root of n. And so let's say for this one, I give you this critical value and I ask you to find the margin of error, then you're going to need to know this formula, right? So keep that in mind. And then steps 5 and 6 are the exact same as above. You use your point estimate, which remember that's X bar, and your margin of error, which is E, to construct the confidence interval. So you're going to have X bar minus E is less than mu, and X bar plus E is greater than mu. And then you're going to give an interpretation. So for this example, it's the same one as above, right? They gave a survey where they asked 1972 adults how many years of education they have. They found that the mean was 13.37 years with a standard deviation of 3.13 years. So because I'm trying to estimate mu, so want to estimate mu without knowing sigma. And so what calculator function are you going to use here? Is it going to start with, so first try and figure out, is it going to start with a Z or is it going to start with a T? Or is it going to start with a prop?
T.
Yeah, it's going to start with T because you don't know sigma. So whenever you don't know sigma, that's when you use T. And then because you're looking for an interval, you're going to use T interval. And so here, when you go and you put everything in, so that's just kind of like, that's what you're going to be using. But the first thing you should do is you should check the requirements, right? So that was just kind of figuring out what type of problem we're dealing with. And so for the requirements, is it random? Yes, they randomly asked people. And then n is greater than 30, so it's normal. So our requirements are satisfied. The second thing was to just kind of write out your variables. And so you have X bar is 13.37 S. And if you want to match your calculator, instead of putting little s, you can put capital SX. That's the same thing. And so this is going to be 3.13. What else? What am I missing? Oh, N is going to be 1972, and then C is going to be 0.95. Where's my calculator? Okay, so yeah, that's all you need to give it. And so once you put those things in, so then step 3 would be to put those all into T interval. And so when you do that, oops, so 13.37, 3.13, 1972, 0.95, calculate. So you should be getting something like 13.232, comma 13.508. Is everybody getting that when you use T interval? Okay, cool. So then to interpret this, we can just say we are 95% confident that the mean number of years of education for all adults is between 13.232 and 13.508 years. And so be very careful here, because remember what you're doing is you're estimating this for the population, which means somewhere that you need to kind of specify that it's everybody. So yeah, that's how you solve this problem. So this was done with calculator. So any questions about this one? Cool. I hope this is making sense to you guys, like the difference between interval and testing and stuff like that. So I'll say it one more time, probably not for the last time, but hypothesis testing is one you want to see if the population parameter, like mu or p, that was given to you, you want to test and see if that's a true statement, right? So some company comes in and tells you, this is the mean for everybody. And you as a statistician want to say, I'm going to test that. But when you're doing confidence intervals, rather than testing a given population parameter, you're trying to estimate it. And so you're saying, okay, I don't know what it is, but I'm confident that it's between these two values. And so I'm going to give you a range of values rather than an exact number. And so I hope those two things are very, very, very clear, and the difference between those is clear, especially because when you get to the final, you're going to have a lot of questions that look similar, and you have to know if you're going to find a confidence interval, if you're going to test. So are there any questions about that?
So when it comes down to like seeing whether it's a confidence interval or if it's hypothesis testing, like it won't say it right out loud in the question, or will we have to find it?
Sometimes it will. So like for both of these, it says construct a confidence interval, right? But if I go back to, let's see, if I go to the 8.2 and 8.3 summary, where we had a bunch of examples here, it doesn't say anything about testing, right? It just says, can you conclude that the mean balance has decreased? It doesn't say anywhere perform a hypothesis test. And so you kind of have to figure out based on what you're given. So whenever you're given significance level, are you testing or are you estimating?
Testing.
Testing, right? So whenever you're given alpha, you know you're going to be doing a test. And whenever you're given the confidence level, you know you're going to be given, you know you're going to be doing an interval, right? And then another way to kind of tell is here it gives you mu, but when you're estimating, you don't know mu at all. And so if you're given mu, you can't be constructing a confidence interval. There's no point. If you know what mu is equal to, what's the point of finding a range of values for it? Does that make sense?
Yes, thank you so much.
You're welcome. So yeah, I want to say at some point, so here's practice problems that I still haven't posted these solutions because all I've done is the z-test stuff. I haven't gotten to t-test yet. But so here's the 8.2 to 8.4 practice problems. And so things like this, sometimes it'll say determine if we should reject or not reject. And so sometimes it'll be very clear, sometimes it won't. And so yeah, you're kind of just gonna have to like make sure that you can figure it out regardless of if it's clear or not. And so again, if you're given alpha or mu, it's a test. If you're not given those two things, it's an interval. Isn't this stuff kind of fun? Aren't you liking this? I like this. I'm sure you guys knew that though. Any other questions? Okay, so I'm gonna stop the recording now and talk about something